Hey guys, so we are now live, and I'm back with the third session of this lab series where I would actually talk about learning electronics. Hey guys, so we are now live, and I'm back. Okay, sorry about the feedback loop. I had to turn off the speaker from my desktop. So anyway, yeah, this is the third session in the lab series where I will actually talk about learning electronics through using the Ultimate Starter Kit by Adept Studio, and then also together with the 42-in-1 sensors kit by Adept Studio as well. So both of those kits, I will provide the link to their products, to the product page after the session. All right. So I'm just going to take a quick moment to sort of get myself oriented, and then we are going to start in a very, very quick moment here. So just one quick second. Okay, so basically I'm trying to sort of create to view the live chat on my phone in case somebody actually decides to write a comment or something so that I can actually reply. But yeah, but I can still reply to the live chat window on my desktop. So anyway, I'm going to talk about what you're going to need for today's session. All right. So I sort of put up the list in the description below as well, so you can go and take a look at it. And basically, those are the things. But there are two items that I actually left out, and those items are actually the potentiometer. So we're gonna need, as in you are gonna need at least you need two 10 kilo ohm potentiometer, all right? And everything else is stated in the description. So we will be using two breadboards. I have a long one here, but actually the medium size one is actually good enough. So you can use the medium size breadboard. This is actually, it comes available with the uh, sensor kit. So I think the sensor kit has this. No, I'm wrong. Okay, it doesn't have this. So I took a spare one from my own Arduino kit. Okay, so anyway, then this is from the Ultimate Starter Kit. So the Ultimate Starter Kit itself has the full length version of the breadboard. So we're going to use that, right? So likewise, we will need two Adapt Studios Arduino Uno, all right? So that's what we're going to need. Um, two USB-A cable. They do have in the sensor kit itself and the Ultimate Starter Kit, they actually have the IR receiver. Okay, so let me just bring it around. Let me open it. Let me know if you are hearing me okay. Leave a comment if the sound is okay and the video is okay. Just let me know, all right? Or if there are any issues. Okay, so we have the IR receiver. This comes with the Adept 42-in-1 sensor kit. But one thing that I find odd is that they have the IR receiver sensor, but they don't have the transmitter. So I don't know, I would think that if you have a IR receiver, it would make sense to also pair it with the um, sender. So yeah, the transmitter. So anyway, you're gonna need that. All right. So in this session, I actually bought this from Lazada. That's where I'm from. In Singapore, most of us shop through Lazada, but you can get similar stuff from Banggood.com, from eBay, from any of the, or even Amazon. So they come really cheap, right? I got this like I remember from Lazada. I got this for like only one piece is maybe $1.50 Singapore dollars. So that's about $1 US. So it's really cheap, really affordable. So you can just buy a bunch of this, right? And they come in handy. So I was using this for a previous home automation project. So I realized that the Adapt kit doesn't have the transmitter. So I decided to just repurpose it for this live session. Okay, so oh yes, the other thing that you're going to need is the 4x4 keypad, right? This comes with the ultimate starter kit for Arduino. So when you get the kit, this is already available. So we're going to be using this as well. Now, another thing that I am using that I would recommend you to use if you are following along with the session and you actually have the kit. So this is actually the guidebook. Okay, so this is actually the guidebook. So you can use the guidebook as well, right? And then, you can follow along because everything else is there. The diagram is there. So you can take a look at the diagram and look at how the connections are being made. Right. So anyway, I'm going to go through all of this myself. I don't memorize. So I sort of realized that, hey, since there are diagrams there, there's fixing pictures, must as well make use of it. Right. So yeah, that's and also, a lot of the codes are available online. So, we can download the code from their website. And actually, they come with the CD. I'm not sure if they have it online, but it's in the CD. So I actually copied the source codes over to my laptop, all right, into my external hard disk. So later on, we can actually copy and paste some of the code, so you don't have to see me type everything from scratch. And then we're going to just modify the project. So what are we going to build today? Today we want to build a sort of a prototype for, say, a IR chatbot. I know IR chatbot, who really use that, right, in the real world. The whole idea is that it's not really so much for a real world use case right now, but it's really just to showcase how you can make use of the IR sensor, how you can make use of the 16 by 2 LCD display, and also how you can make use of the 4x4 keypad. And we all put it all together into one single project. Right, and everything here except for this sensor, everything here is available through the kit. All right, so yeah, all right, so let's get started with it. All right, so the first thing that we want to do, that I'm going to do, is to connect the LCD display. So I'm just going to follow the book here, and then I'm just going to explain along the way. Okay, so you need to connect the 5 volts. Okay, so from 5 volts, we are going to connect to the positive rail on the breadboard. Okay, let me see if I can just bring it up a bit so you can see it better. I'll need to focus the screen a little, so bear. I'm using a webcam, so I have to sort of manually focus. So you can see, okay, so it's to the positive rail from 5 volts. And then we will take from ground to the ground rail. All right. So if it's your first time learning electronics and you have not actually followed the lessons before, the positive rail, the voltage rail is actually the one with red. The blue color rail is the negative. All right. And then on the breadboard itself, if you have not watched any prior tutorial, how they are connected is they're connected by each row. So you can see that I know it's inverted. So you can see that each row is labeled with a number. All right, so those numbers basically show you each row that is connected to each other. All right. Okay, so next, let's continue with the other pins. Mm. So let's connect the potentiometer to the ground and voltage source. Okay. Okay. So this is just going to move it forward. Oh. I thought it's good to take this opportunity to highlight to the guys at Adept Studio. I've bought and used many electronic kits before, but somehow, when I'm using the breadboard that comes with their kit, I do realize that some of the slots are a little bit hard to push items in because somehow I'm not very sure. Maybe the contacts are really tight or they are not properly aligned. But yeah, I thought it's worth pointing out to the guys so when they are packing the new kits, they will actually take note of it. Okay, so for the potentiometer, ground would be the first pin to should be to your. Let me see. If you are viewing this, it should be to your left, the left furthest pin, right? That's ground. For positive voltage, it will be the furthest pin to your right. Okay, and then now we need to connect the voltage source for the LCD display. So we'll start from the pin furthest to your right, and then we will move to the left. All right. So then we will connect the ground. Okay, just want to make sure that you guys can see it properly. Mm. Okay, so yeah, yeah, you should be able to see it better now. And then we'll continue with the so the third pin from the right will be connected to the potentiometer. That is actually basically for adjusting the brightness of the LCD. Okay. Next, fourth pin will go to pin um, digital pin number 4. We need to connect another one of it to ground. Next, take a yellow. So next one would be pin number 6. Okay, so just want to make sure you can see it properly. So it's 4, all right, 4 and 6 so far on the Arduino board. Okay. And we'll continue next. So I've connected the yellow. So we're gonna skip. Let me see here. It looks like we will be skipping about 4 pins. Mm, 4 pins. So on the LED, we will display for the LCD display. We will skip 4 pins. All right. So 1, 2, 3, 4. Okay. We will be skipping 4 pins. I know the yellow wire is blocking, so we are skipping 4 pins. Is it 4? Oh, I blocked it wrongly. Wait. 1, 2, 3, 4. So, okay. And then that will go to the PWM pin number 10, 8, 9, 10. Now, the thing is this, I will do a sort of like a short video, pre-recorded video after the live session. This pre-recorded videos is something that I want to introduce to the lab series so that it can be added to the post-session articles in the future. In that way, for people who are sort of like they miss a live session and they come back to watch or to read the post-session tutorial article, they don't have to like spend the next 1.5 hours to see sort of watch the whole live session. They can just watch the pre-recorded video. But I figured that there are people out there who enjoys watching live sessions, and live sessions provide opportunity for them to ask questions, and also for the lab instructors like myself to actually answer questions on the spot. So there are certainly benefits for having a live broadcast. So that is why we're going to have both options, live broadcast as well as a short post-session video. All right. Okay, so I'm going to just continue. The next pin will connect to 11. And then take the green. Honestly, I find that you don't really have to follow by the color because, I mean, the diagram is there. So as long as you can follow the diagram and you can understand the diagram, I think it's fine. Mm. Okay, so this is interesting. Just as I'm doing this, I'm sort of thinking to myself, how am I going to connect the? You see, this is the thing. The breadboard is it's a bit hard to just push the pin in. Okay, now the wiring is officially getting very messy. Okay, so while I'm here, doing this, I was just remembering, for you guys, if you are really interested, please do check out this brand called Semtech. All right, Semtech Inc. is one of our sponsors, our brand sponsors, the very first brand sponsor that supported our lab series. They specialize in cabling and sockets. All right, so they sort of make. Let me just take a sample and show you. They make really nice cables. So if you know that you need to connect cables in a certain arrangement, like a number of pins, I'm just going to move this away for a while. Like the rainbow cables. These rainbow cables are actually by Semtech, right? So you can see that they actually have the uh, headers here, the female headers. You can use to sort of plug into pins, right, on a breadboard, anywhere that has pin headers. So do check out Semtech Inc. They let you customize the cable, set the length and the number of uh, pin slots you need. So it's really, really good. And, it definitely beats messy wires like this. All right. But yeah, this is just a tutorial, so we're just going to continue with it. But I'm just thinking about some idea of how to actually lay out the IR receiver later on. Okay, so let me just keep this. I'll just continue in a moment, guys. So anyway, hey guys, I thought it was also worth mentioning. I've officially reached out to the custom PC workstation guys. There are two brands. One is Aftershock PC. One is Digital Storm. So basically, two of those brands are the brands that I'm trying to target to sort of build a partnership so that they can actually sponsor their workstation to lab series, at least for the online educators. Because I do realize that everything that we are doing and the demand that's growing from the brand partners, the community that's growing, we really need the right hardware to support what we are doing. So I've already reached out to them and just waiting for them to get back to us, or to get back to me. And then, right now I'm running everything on my MacBook. So, right now, even though you might not be able to hear it, you might be able to hear it, but my MacBook's fan is sort of making a lot of noise as well. So, yeah, it's sort of overworked. Uh, but yeah, it's just the humble beginnings, I guess. But yeah, I'm looking forward to the brand partnership with either Aftershock PC or Digital Storm PC. So, the rig that they will be providing, if they do sponsorship, it will be one super powerful rig that can do AI research and development. They can do video production as well as serve as a NAS, right? A network access storage. So it'll be super amazing. I'm really excited. I'm looking forward to that prospect. Okay, enough checking. Uh, Next, we need to connect the last two pins. All right, so the last two pins, likewise, are actually the ground and voltage. So voltage source. Okay, so maybe mini, the medium-sized breadboard might not seem like a very good option to use for this project. So probably might want to take note of it. I think that is meant the longer full length breadboard is probably much more suitable. Okay, ground. Okay, so we have connected all the right pins, I would assume. I'm just going to double check the pin connections again and make sure that everything is connected properly. Okay. Voltage. Voltage. Four. Okay, so this is correct as well. Okay, so now we're going to connect the USB cable. So if everything is connected properly and correctly, oops, sorry. If everything is connected properly and correctly, the LCD display should be able to adjust the brightness by turning the potentiometer. So, okay. So yeah. So when we turn the knob, it will actually set the display. Just want to make sure that it's fastened properly. Okay, so, all right. So that's good. The connection is so far so good. Next, we will then put in the coding. So I am going to switch over to the platform IO that runs on FM. I'm going to talk a little bit about it once I switch over. So give me a second. Okay, so this is actually the platform IO IDE. Sorry, this is the Atom IDE. It's free, you can download it. And then you can download the platform IO development environment. It's basically a platform actually. It's not an IDE per se because you don't code on it. But I really like the guys at Platform IO for creating this tool. All right. So once you have downloaded it, you will need to create an account. So thanks to the guys at Platform IO for actually uh, sponsoring us with the software, the subscription. I really appreciate that. I really love everything about it because it makes embedded systems development so much more convenient. And then on top of that, they are able to tap onto Atom IDE that allows you to have IntelliSense and so on. So that's very good. Um, Based on the recent Arduino Day, all right, 2018, the team at Arduino did reveal that they will include they are improving the Arduino IDE And then in future there's going to be plans for IntelliSense, but I think that would probably, I mean, it won't happen so quickly, probably not so soon. But yeah, I mean, I look forward to the update because then for a lot of beginner users who's learning about Arduino IDE, the IntelliSense will be very, very helpful. But in the meantime, I would recommend that you try out and check out Platform IO, right? So with Platform IO, basically, you can create a new project, right, from the home screen. You can set up your project name and then select a lot of different bots that are available and supported. Now, if there are bots that are not supported yet or not in the list, you can always feedback to the Platform IO team, and they will actually look into it as well. So you can provide like a improvement or a feature suggestion to them, right? Okay, so once you have selected a bot, okay, let's create a new project in this case. Let's call it our chat bot. So we are using a Arduino Uno. This is a compatible board. So here it allows you to select the compatible framework that's available. And the framework is something that you can install under the platform's option, right? So we will create a project in, say, Arduino, and then we'll use the name. Just press enter. At this step, press enter. So it's a lot easier. You just create the folder. Because if you don't press enter and you click finish, basically it will save your project file in the root folder instead of the project folder itself. So we are creating a new folder. Remember to press enter, and then you will create a folder and go into the project folder itself. And then you click finish. Okay. So next thing, we actually have I have the lesson 11 LCD 1602 that's already available. So we are just going to copy and paste. Yeah, I'm just going to quickly go through it. But I'm not going to go too much into detail of the theory part because online lab series is really more about application. So we usually would assume that you have probably done the basics and you sort of just want to explore further, all right, to find out more. So I won't really go into the basics here, but yeah, basically this is just an array of strings that you want to send to the LCD, all right? We set the delay timer, and then you will need to initialize the LCD display, right? So these are actually the pins that we have set up, all right? So the ones that are connected to Arduino. Okay, so LCD begin, I remember correctly, theoretically, this is actually referring to the number of characters, the space, and then this is the row. So if I'm wrong about this, yeah, just point it out to me. But I think I'm correct. Okay, so within the loop itself, you'll clear the screen each time it's being looped. And then basically setting cursor will tell the LCD display at which cursor do you want the text to start being printed. Right? So in this for loop, basically, if I'm correct, this for loop, yeah, it's basically printing each character from the string array. So it will print out each character based on the position. Okay, so one thing that is good to take note is that This is something that I've encountered myself as a Arduino learner and maker when I was using the LCD display for the first time. I don't remember anywhere online that actually stated that when you print a character, they will actually automatically append to the end of the line. Um, Even if it was mentioned somewhere, I don't remember seeing it, but I did a lot of research, but I couldn't find the information. And then I have to sort of figure it out on my own after debugging a display that was not displaying data correctly. So then I realized that, when you print characters on the LCD, once you set the cursor, every other character that you print after the cursor will just append to the end of the line. So if you want to say display a string on a different line, so if you scroll down, the example code here set the cursor at the first character on the second line. So each line, it goes by index in programming. The first row is usually 0. The index is 0. It's not 1. Okay, so 1, in this case, the index 1 will refer to the second row. Well, that's in programming context. So anyway, I'm just going to take a quick moment to take a snapshot of this and also post it on Twitter. So part of my social media marketing. So just give me a moment, I'll resume. Okay, yeah, thanks for being patient on the other side of the screen. Yeah, so we're going to execute and then compile this project onto the Arduino board. So if you go to the uh, left-hand side, right, under the toolbar, okay, the two things that you need to do here is very simple. You can straight away build the project. So once you build a project, it will automatically save the project as well. Okay, so if there are no errors, it will just show that it's successful. Then the next thing we're going to do is we're going to upload it to the Arduino board. Okay. Okay, so I'm just going to shift the display a little. I hope I don't knock over the camera. So I will stop the screen share for a little while so you can see the display. Okay, so basically now you can see that the display is displaying the text that we were trying to send to the LCD. Right. I'm going to try and focus if I can. Okay. If it's not very sharp on YouTube, guys, don't worry. In the post session recorded video, it's going to be a lot better as well. So if you're stay in a location where you can only view maybe 360 pixel resolution or 480 pixel resolution. That's fine. Okay, so now that that is done, the next thing that we want to do is we want to incorporate the IR. All right, so in this case, you want to use the receiver module, okay, the IR receiver sensor. And so you will need to take out from the sensor kit. They have this connection connecting wires, so it's really easy and convenient. So I'm just going to remove this for a while. So you are going to need this from the sensor kit. Let me see if you can see it. Okay, so you'll need this. All right, so they have a few options. Take the one with um, 3 pins. All right, okay, and then we're going to connect it. So there's only one way to connect anyway. There is 2 slots here, so we do connect. Okay, and one way you can verify that connection is correct, and you can't go wrong actually, is that okay, so black, black wire goes to ground, the negative sign. Red goes to voltage source, which is the positive sign. Yellow goes to signal, right? So it's quite straightforward. So under the booklet, right? If you have the booklet, we will go to hmm, private 59. So page 59, right? It is lesson 17. So now I do think that okay. So in platform IO, okay, we're going to go back to platform IO now. Okay, so one of the things that if you want to know where your libraries are installed and whether or not you have installed a library, one way is to go to platform IO home, go to libraries, and then go to the install tab. And you'll be able to see all the libraries that you have downloaded and installed. And so we are looking for the Arduino IR. Mm, is it this? Hmm. Let's look for Arduino. Okay. It's not available. You can go to GitHub, right? And then from GitHub, you can look for I'm just going to go over share the browser window. 1 second. Okay, and then we will search for Arduino. This should be the one. Okay, so we will download. This is it. Okay, so where to save it? Go to your root folder. I'm on Mac. Windows, I think, is under your user directory. Okay, so in this case, I can't really see it. So save the downloads first. Let's just put it on the desktop. Let me just share my whole entire screen. I think it would be easier to see everything. Give me 1 second, guys. I'm just turning on my notification before I share my entire screen. Okay, so you should be able to see my entire screen. Okay. Okay, so let's go to. Okay, so under your user directory, if you're using Windows, it should be in your user directory. In Mac, it'll be in my user directory. So just go look for the directory that has a dot platform.io under lib, which is library. Okay, so apparently I did have the Arduino IR remote library already installed, downloaded. So okay, so once that is done, let's take the code from lesson 17. All right, this is from the source codes that comes with lesson 17. So do you know starter kits? So there are all these lessons here. So one of the things is you can say that I'm a bit of a lazy guy. So, but I always believe in working smart anyway. And if there's a chance to sort of reuse and copy people's code, I don't see a point of trying to um, recreate everything, right? Lesson 17. Okay, so we will need to include the library file. And pin 11 is used. Okay, we will use pin 3 because pin 3 is available. So the receiving pin. Okay, so in this case, our yellow wire, I'm just going to. So the yellow wire will go to, we'll use pin 3 in this case. Pin 11 is in use. It should work, I hope so. And then ground to ground, all right? You should know that by now. And voltage to voltage wheel. So if everything is connected properly, the LED should light up. So okay, next. We go back to platform IO. And then we will need to copy the rest of the code. So let's just put it here. Remember that we changed the receiver pin to 3. And then we will need to set up the serial. This for serial communication so that we can print out what is being received. Okay, so we are going to let's just hide all this code, comment it for now. We're not going to use it. We're going to modify it later on anyway. Okay, so what we want to do in this part of the lesson is to be able to decode the IR when something is being transmitted, right, or received um, on the Arduino side. Okay, so we're going to compile this and send it over to the Arduino. So one thing I like about Platform IO is that when you save your project, it automatically compiles for you, which is something that I like. And then we will upload the code. Okay, so what I'm doing here is really everything step by step. So if you are working on a physical project, this is also kind of the steps that I would recommend doing because it's sort of a best practice as well. Sometimes if you try to code too far ahead in the project without considering other aspects of the project, you might end up spending a lot of time and effort writing a lot of code that you need to change or remove later on. So sometimes it's good to just do it step by step and not rush through the process. So the next thing that we want to do is we're going to remove this current project. Let me just, so I'm going to remove this right now. And we're going to use the fresh Arduino Uno, the next one. Okay, over here, with this. And we will use uh, this is the IR transmitter, all right? This is the receiver. So we will put it here. The reason why I want to do it this way is so that, when I lay out everything together later on, the transmitter and the receiver can we can force it to face each other to test the transmission in between, okay? So we will skip the LCD portion for now, and then we will connect the transmitter. Okay, so in this case, we want to transmit the signal, right? So we will need to put the TX pin. We can go to the Arduino remote example, Arduino IR remote example. So let's just okay, so let's look at the example. So we have the IR send example here. Right, we're going to use this. Hang on, let me see if there's another example. Okay, so we can actually send. Okay, how do I do this? This is the thing that I like about doing product application driven videos. It's not like doing just the basic theory and stuff, but we really try to think about how we can send information. Um, yeah, how you can send information outside of the normal way of doing things. So it will make you want to think about how to do it, right? And sort of figure it out along the way. Okay. Hmm. How do we send the signal? Let's go to the library. This is not correct one. Okay, so yeah, okay, we can use sort of like a constant, all right? So if you look at the coding example, we can define hmm, okay, let's just put the code in there. We'll see in IntelliSense what comes up. Okay, so let's create a new project in this case. Let's call it our chatbot. Okay, so same thing. Remember what I said earlier in the session. Once you are creating a new folder, press enter on your keyboard when you want to create a folder for your project, then click finish. So now that we have this project, we can copy the coding we need, and then we will define the let's so let's say we want to set option. Maybe set as so if I'm correct, that is actually hexadecimal 0001 should be 1 because 2 is 0010. Oh, correct. I don't. The thing is this. I sort of picked up embedded systems development what only a year ago. So there are a lot of things about embedded systems development, hardware system development that I'm still learning. If you ever want to sort of, sometimes it's just for the fun of it. Um, to, oh, yeah, there's always ways to do that. So maybe same one. So is 001. So if we take 2, oh, is this correct? 3, or binary number. Oh, that's binary. Okay, okay. So in hexadecimal is 003. So I kind of forgot about that, guys. I apologize. 3. So if you want to know binary, how do you write it? Binary code is, I think, 0, 0, B, 0, 0, 1. And then if this is basically 1. If you want to get the number 2, 0, 1, 0, 2. Of course, if you want to use all 8 bits, I hope I say it correctly again. 8 bits, there be 0, 0, and then so usually in a readable format, it looks something like that. Okay, so that's for uh, binary. We're not going to use that here. So the reason why I am creating these options is basically to mimic what we have here, right? I mean, what I'm creating here is actually the options available by units. So the whole idea is that when you press a particular number or letter on the 4x4 keypad, we want the Arduino to send that hexadecimal data to the other Arduino that we saw earlier in the session. So that's what it is. While I'm actually doing this, I sort of realized that this session could actually go on a lot longer than I have planned or intended. So there's a good chance that I might actually split this tutorial or lab session into 2 parts. Okay, so we have up to 9. Let's look at what is the hexadecimal for A. Oops. Let's see. But just one letter A. Hmm. Would this be 0x0041? I'm trying to figure that out. Try this. Okay. So I think it's actually option A 4x00. Okay. B, I would assume B is 42. Yeah. I always like to align my code because I think that when you align your code properly, it's always a lot more readable. It's always good coding practice as well, right? So that's just a little tip. Okay, actually, if we put small letter A, I think small letter A is 10. So we can try that. Small letter A. Oh, no. Okay, that's weird. Oh, it's 61. Hmm. Maybe because uh, the caps go first. The small letters? I can't remember. Let's try A, B, C, D, E, F, G. So things like that we do and learn. It can help to. Okay, so let's try caps. A, B, C, D, E, F, G, H, I, J. So let's convert 50. Okay, so the last one ends at 5A. So 5A, okay. Okay, next we will try small caps. Okay, so 61. Yep. Okay, so if you notice, 1, 2, 3, 4, 5, 6, 7, 8, 9. Once it reaches 9, because obviously in hexadecimal, it doesn't have 10, so it starts from A, B, C, D, E, F until F, and then it goes back to 0 again. So yeah, something that you guys can think of and remember. Okay, okay, so we have that set up. Next, we will do the transmission. Where was the code? Oh, it was actually in the example. Same thing, we will set up the serial communication. So I was saying earlier, I was wondering if there is a method to send just a normal output. So let's see what we get. Oh, I haven't set the, so you need this. All right, so guys, always remember, don't forget to initialize the object, right, that you want to use in your code. Otherwise, you will not get anything. Okay, so send send raw. Yeah, I don't memorize the coding, so I kind of forgot what I need to put inside the send raw. So hmm, I'm just trying to figure out this part. Does anybody know if there are any libraries that we can use to just send a hexadecimal simply? No, actually, that's a pointer, right? So anyway, I'm just trying to figure this part out. Okay, you know what, guys? I'm just going to end today's lab session here first. This will be part one. And then next week, when we come back, I'm going to explain how we can send the hexadecimal data using IR transmitter to another IR receiver. And then I'll show you how you can receive and then decode into the right format. So Basically, today what you've seen is you have seen the 1602 LCD and how we can set it up, right? So that is done. And then next week we will follow up on the IR transmitter receiver as well as the 4x4 keypad. All right. So thank you very much, guys. I did have a lot of fun tonight doing this. Although, I wish I could have done more, but I think that I will need to go and figure out the part about the sending the data. So, and who knows, I might just add additional coding into the library file to have a method for just sending raw data between two sensors. All right. So, yeah. Okay. Thank you very much, guys. Until next week, I'll see you again. Bye.